So 6.1 is all about laws of exponents and all that, and we have some definitions we want to talk about first. This is straight from their curriculum notes. So first, these two kind of go hand in hand. So when we deal with exponents, we have what we call a base, all right? And a base is a number in exponential form that appears beneath the exponent, right? And the exponent is a small number raised, a small raised number that tells you how many times to multiply the base by itself, which means we have the base raised to some exponent, all right? And this exponent tells us how much to multiply the base by itself. So in this case, if I had something like 4 to the third power, right? That tells me I'm going to multiply 4 by itself 3 times. So the 4 to the third would be 64. Okay? Now, with that, we have exponential expression, and it's any expression that involves an exponent. Right? So if you see an exponent anywhere inside an expression, you know it's an exponential expression. Now, I'm going to come back to fractional power and all that. Actually, let's talk about power. Power is basically the same thing as an exponent. So if I have some base raised to some power, it means the same thing. So 3 to the second power, right, is the same as 3 to the second exponent, right, or exponent 2. Okay, fractional is anything to do with fractions, and square root we'll come back to. So here, if we had to label each part of the diagram, right, then use the labels to complete the sentences. When I look at here, B is your base, N is your exponent. Okay, so B to the N is called an exponential expression. So when we look at it, the base, right, tells what number to multiply by itself, and the exponent or power tells how many times to multiply that number by itself. Okay, so if we had to look at this chart here using exponents, so right away here I'm multiplying 5 times 5 times 5 times 5. So if I had to write what the base would be, what am I multiplying by itself? 5. What's my exponent going to be? 4. And how would I write this as an exponential expression? My base of 5 to the 4th power. Here I have 7 times 7 times 7. So my base is 7 because that's a repeated multiplication. How many times did I multiply it by itself? 3. So this would be base of 7 to the 3rd power. Now if I multiply these out, right, notice how 5 times 5 times 5 times 5 would be 625. So 5 to the 4th is 625. 7 times 7 times 7 is 7 to the 3rd, which is going to give you 343. Now the next one, I have 2 times 2 times 2 times 2, blah, blah, blah. So my base is 2. How many times am I multiplying by itself? 7. So I would write that as 2 to the 7th, which is 128. So 9 times 9, base is 9, exponent is 2. I would write that as 9 to the 2nd power, which is 9 times 9, which is 81. Now, if my base is 3, my exponent then is 5, and I would write this out or expand it as 3 times 3 times 3 times 3. I would multiply 3 by itself 5 times. Alright, so organizing information, it says here, number the following operations in order they should be done. So if we looked at order of operations, okay, order of operations, which is probably what you've seen. Please excuse my dear Aunt Sally, right? So when I look at this, P stands for parentheses, E stands for any exponents, multiplication or division, right, is next. But you have to do whatever comes first from left to right. Okay? And then addition or subtraction. And again, whatever comes first from left to right. Okay? So when I look at this, which one of these would we do first, right? We would do any operations inside grouping symbols, which are also parentheses. Okay? Then we would evaluate any exponential expressions. Then we would do any multiplication or division. And finally, any addition or subtraction. Okay? So, let's look at the examples here. So right away, when I look at doing example 1, I look and I see parentheses. So I'm going to go inside the parentheses and I'm going to do that operation. So I get 6 plus 4 minus 2 times 3 squared is 9, and 9 minus 5 would give me 4. Now, as I read left to right, that's addition, subtraction, multiplication. I'm going to go ahead, stop, and do this multiplication. 2 times 4 is 8. Now, when I look at it, addition or subtraction, 6 plus 4 is 10. 10 minus 8 is 2. So the next one, I'm going to stop and I'm going to do what's inside this parentheses and this parentheses individually. So here, right, we're going to get 3 plus 5 is 8 squared divided by 3 squared is 9. 9 plus 7 would give me 16. So now I have to do the exponents. So 64 divided by 16. Now I can do the division is 4. Okay. This last example, I'm going to do the innermost parentheses first. And you have to do the operations correctly. This would be 12 divided by 4. I have to do exponents first. So this would become 5 squared minus the brackets, 3 times. What is this going to become now? 12 divided by 4 is 3 plus 4. Now I'm going to go ahead and do what's inside the bracket now. And at the same time, if I want, since this is outside, I could do 5 squared is 25 minus 3 times 3 is 9 plus 4. Now I can just add or subtract the way I see it. 25 minus 9 is 16 plus 4 would give me 20. Okay. So that's using order of operations, and you would follow the steps up here. Now, exponents have properties, right? And when I look at the properties of exponents, right, if I have the multiplication rule right away here, if I multiply same bases, notice how I have b and b. I can write it as 1 base of b, and then I can add the exponents. So if I were to go over here and simplify this, this would simplify. I could, if you look at this, if I write this out, that's 3 to the 4th times 3 to the 2nd. How many 3's am I multiplying together? 1, 2, 3, 4, 5, 6. So this would be the same as 3 to the 4 plus 2, which gives you 3 to the 6th power, right? Now, anytime I divide, right, I can, if I look, and you have to identify, my bases are the same. So I can write this as 1 base of b, and here I would subtract the exponents, okay? And if you look here, if I have 4 to the 5th over 4 to the 2nd, 4 times 4 times 4 times 4 times 4 over 4 times 4, these 4's cancel, these 4's cancel, so what am I left with? 4 to the 3rd. Now the easier way to do that is to know. I can write it as 1 base of 4, subtract the exponents to get 4 to the third power. Now I could take that further by doing 4 times 4 times 4, which would be 4 times 4 is 16, times 4 is 64. Either of these answers would be correct. Now if I raise a power to a power, what I do is I end up multiplying these together. B to the n times m. And if you think about this, it's no different if I do 5 squared raised to the third power. That's 5 to the second times 5 to the second times 5 to the second, which is 5 times 5 times 5 times 5 times 5 times 5. How many 5s do I have here? 1, 2, 3, 4, 5, 6. So this is 5 to the 6th power. But I could have easily just done 5 to the 2 times 3 and got the same answer. When I have a times b to the n, I can basically raise each number inside the parentheses to that exponent. So here this would be 3 squared times 4 squared. If I wanted, I could leave it like that or simplify it to 9 times 16, which would give me 144. The quotient law, right? When I look at this, I could do a to the n power over b to the n power. So here this would be the same as 2 to the third over 5 to the third, which would be 2 to the third is 2 times 2 times 2, which gives you 8 over 5 times 5 times 5 would be 125. This answer or this answer would be acceptable. If I have a negative exponent, if that negative exponent is in the numerator, I can bring it down below. If it was in the denominator, right, I can bring that up to the top, and it makes, if I move it down, the exponent becomes positive. If I move it up, the exponent becomes positive. So 6 to the negative 2 is the same as 1, right, over 6 squared, which is 1 over 36. And anything to the 0 power is just 1. Okay. Next, we have square root. Square root is the same thing as a radical. Okay. And when we go up here to the beginning, you can write this definition down. A radical is a square root, which is this symbol here, where you have, this is your root, this is your radicand, right? And the principal square root is the positive square root of a number. The principal square root of b is written as the square root of b, which means, if I look at it, the definition of it is if n squared equals m, then the square root of m is n. And if I put this in number, it basically says if, say, 3 squared equals 9, then we say the square root of 9 is 3. So right away when I look at it, the square root of 16, what to the second power would give me 16? That would be 4. So what is the square root of 25 going to be? What to the second power would give me 25? 5. Okay? So that's what the definition of principal square root is. So this here, right, when I look at it, this is the radical or the root. Okay? So the number that goes here, again, is the root. And you'll see what I mean by that in a minute. And then b is known as the radicand. So when we talk about a radical, that is that little symbol there. So the expression, right, this symbol means the square root of b. Okay? Then the next one says the blank symbol stands for the exponent 1/2. Right? So we say the radical symbol stands for the exponent 1/2. So when we see this, what that means, I know the square root of 9 is 3. right? So what we say is 9 to the 1/2. 9 to the 1/2 is the same as square root of 3, and 9 to the 1/2 is 3, right? So the square root of 9 is the same as 9 to the 1/2 power. Okay? The number expression under the radical symbol is called the radicand. So here, every positive number has two square roots. A principal square root and its opposite. Okay? Meaning, to be honest, like, as long as you know the principal square root, we talk about, like, if I have x squared, right? The square root of x squared is basically x, and that can be positive or negative. So b to the 1/2 power is the principal square root. It has a property b to the 1/2 all to the second. Remember, what do I do with the exponents here? I would multiply them, and 1/2 times 2 would be b. Now, the square root rules mean I can break this up into the square root of a times the square root of b, right? I can break it up into the product of two radicals, or I could do the square root of 3 times the square root of 4, and in this case, that would give me this square root of 3 times the square root of 4, which could also be, I can't take the square root of 3, so I would keep it the same, but the square root of 4 is 2. Now the book just wants you to do the root 3 times root 4, but I would take both answers here. So the quotient law is saying I could break this up into the square root of a over the square root of b, which in this case would be the square root of 2 over the square root of 5. So if I look here, I could break this up square root of 4 over the square root of 9. What is the square root of 4? 2. What is the square root of 9? 3. Done. Now 4 to the 1/3 to the 1/3 power is 4 to the 1/3 times 3. And a third times 3 is just going to be 4 to the first power, or 4. And no different for number 3. 5 to the 7 times 1/7 would give me 5 to the first power, which is just 5. Let's look at some quick examples here. Using the laws of exponents, this is going to be 5 to the 3 plus 4, which would be 5 to the 7th power. When I look at this, since it's in the numerator and the exponent's negative, right, I would make this 1 over 3 to the 5th power. The next one, I'm going to multiply these exponents to get 4 to the 15th power. So that's 4 to the 3 times 5, which is 4 to the 15th. Number 4 would be 5 to the 9th times 4 to the 9th. And because that would be a really big number, just keep it as that. And when I look, 2 over 7 to the 6th power would be 2 to the 6th over 7 to the 6th. And the last one, if I'd evaluate 81 to the 1/2 power, that's the same thing as the square root of 81. And the square root of 81 is just 9. So here, the square root of 64 times 121 is the same as the square root of 64 times the square root of 121. Now if I look at that, is there a number to the second power that gives me 64? Yeah, 8 times what to the second power gives me 121? 11. 8 times 11 is 88. If I had to rewrite this using exponents, I would rewrite this as 7 to the 1 over 3, right? And the reason it's 1 over 3, that becomes that. The next one, 9 to the 1/2, is the same as the square root of 9 over 4, which could be broken up to the square root of 9 over the square root of 4, which becomes 3 over 2. And the last one, 4 to the 3rd to the 1/2, would be 4 to the third to the 1/3. When I multiply these together, I'd get 4 to the first power, which is just 4. Okay, go ahead, try the quiz, and let me know if you have any questions.